Look up. What do you see? Probably ceiling tiles. Scrap that. Burrito. Go outside. Look up at the sky. What do you see? That is all predetermined. If you see this, you might be under a mid-latitude cyclone or a sheet of clouds. If you see this, you're in the clear and the barometric pressure is high and happy. Or maybe all of the clouds are being absorbed into a supercell. If you see this, I recommend you go back inside. Supercells can cause major damage. They can break windows, topple trees, and even sweep houses clean off their foundation. Before I can tell you about all that, I need to familiarize you with the parts of a supercell. This is the anvil. It is where the updraft rams water vapor into the upper troposphere. This is the overshooting top. It occurs when the updraft gives the water vapor so much momentum that it goes into the lower stratosphere. This is the mesocyclone, a vertically rotating column of water vapor that goes upwards all the way through the cloud. This is the flanking line, which are the patches of clouds heading before the storm. This is the wall cloud, which is where tornadoes form. Now that you know somewhat what I'm talking about, I'll continue. The fastest wind speed on Earth at 301 miles per hour was recorded in a tornado off of Moore, Oklahoma on May 3rd, 1999. To put that into context, the strongest wind ever recorded in Georgia was Hurricane Michael in 2018, with wind gusts of up to 115 miles per hour. 115 miles per hour is enough to push a sturdy building down, but it's a light breeze compared to 301 miles per hour. So what might make one storm weaker than another? Well, there are several factors. There's the updraft. The worst storms usually form on cold fronts, where warm air is being pushed out by the denser cold air, causing a rising mass of water vapor to ram into the upper troposphere, making an anvil. There's also another factor, called wind shear, which is when the wind speed at higher levels is different than the wind speed at lower levels, which is what gives cumulonimbus clouds their slant. Wind shear makes the mesocyclone spin faster, which makes the storm more violent and more likely to produce tornadoes. It also depends on the type of storm. It could be a squall line, which is a massive storm that can stretch for hundreds of miles in length and travel across the country. These are less likely to produce tornadoes and hail, but still bring significant rain and lightning. It could be a convective line, which is a shorter line of multiple cells. These are more likely to produce tornadoes and severe weather, yet are less photogenic and have high precipitation levels, making tornadoes very dangerous. It could be a mid-latitude cyclone, which is a rotating storm system which is not as damaging as a hurricane, but is much larger. Mid-latitude cyclones are often more than twice as wide as a hurricane at 1,200 miles wide. Or it could be an isolated supercell, which usually brings the most tornadoes, but are often smaller at around 15 miles wide at most. There are 3 types of supercells: low precipitation supercells, classic supercells, and high precipitation supercells. Low precipitation supercells are storms with high bases and are less likely to produce tornadoes. They have the strongest updraft, biggest hail, and strongest straight line winds. Tornadoes can form in a low precipitation supercell, and when they do, they are spectacular. Classic supercells are the most common and the most likely to produce tornadoes. They have moderate straight line winds and moderate rain. Tornadoes in classic supercells are somewhat visible and may grow to be very large. High precipitation supercells are supercells with very heavy rain, weak updraft, and less likely to produce tornadoes. When tornadoes happen in high precipitation supercells, they are extra dangerous because the rain obscures them from view. What are some tools you could use to predict these storms? You could use a barometer to measure the air pressure, and when it drops, the storm is coming. You could use precipitable water, PW, numbers. PW is if you condensed all the water in a vertical column of air. How thick would the layer of water be? You can measure convective instability, which is how easy it would be to move the mass of air upwards. If the air moves easily, the atmosphere is unstable and would support more of an updraft. Or you could use a Doppler radar, which is what most news channels and weather prediction centers use. See, clouds are neat, and what might seem like nothing is a churning mass of water vapor, creating temperature changes and changing our lives as we know it. That's pretty cool.